Here we determine the minimum cost to create this rectangular enclosure. The area is given as 525 meters square, and the cost to create the fencing for each of the sides is given as shown in this diagram. That is, the cost of fencing is for side AB is $11 per meter, and for BC or for the other three sides, it is given as $3 per meter. So we have to first write down the cost function and apply calculus method to determine the minimum cost. So first I'm going to write down the cost function. So I can write down this as cost. This equals cost of fencing of each of the sides. That is cost of fencing of all the three or four sides. That is the side AB, side BC, side CD, comma side AD. So let X represents the side length AB, and Y represents the side length BC. So basically these are the length and width of the rectangular enclosure. So therefore we can write down this cost. Suppose we determine the cost of the side AB, cost of fencing for side AB, and this equals cost per meter, which is $11, times the side length of AB, which is X. So this is basically 11X. And similarly, the cost of fencing for side BC, and this equals the cost per meter, which is $3, times the side length, which is Y. So this is basically 3Y. And similarly, we write down for the other two sides, that is for side length CD, it is 3 times of the side length is X, so it is 3X. And finally, for the last side, that is AD, it is the cost per meter, which is 3 times of side length is Y, so this is 3Y. Now we will find a relation between X and Y using the area information. We know that the area of a rectangle is XY. So XY equals 525. So from this we can determine Y. So therefore we can write down Y equals 525 over X. So this is the relation between X and Y. We will use this in the cost function. Now let's write down the complete cost function. So I'm going to write down this as C of X, and this equals cost of fencing of all the four sides. So we have to basically add up all these expressions. That is 11X plus 3Y plus 3X plus 3Y. Now let's replace Y as 525 over X. So we combine these like terms, that is 11X plus 3X is 14X. And also we combine this 3Y with the 3Y, which is 6Y. And so now we rewrite this Y as what we have found here, that is 525 over X. So therefore the cost function C of X, we can write down this as 14X plus 6 times of 525 over X. We multiply these two, it is 6 times of 525 is 3150 over X. So basically this expression represents the cost function. So now we can utilize the calculus method to determine at what value of X the cost is minimum. For that, we have to prepare the sign chart for the critical numbers, or for the derivative function. So first, we will determine the critical numbers by finding the derivative of this function. That is, we have to find the C prime of X. We have to set this up equal to 0. So let me find the derivative of the function by finding the derivative on both sides. So C prime of X equals derivative of 14X is 14 times of derivative of X, which is 1, plus I put this constant 3150, and this equals we find the derivative of 3150 over x, and we can rewrite this as 3150 times 1 over x derivative. Because 3150 is a constant, we keep it as it is, and then becomes 3150. This 1 over x can be written as x raised to the power of 1, and we find its derivative. So therefore, we can apply the power rule now. So it becomes minus 1 x raised to the power of minus 1, which is minus 2. So basically, this can be written as negative 1 over x squared. So it is 3150 times negative 1 over x squared. And this means we multiply this with the negative 1. So it becomes negative 3150 over x squared. So we can replace this as negative 3150 over x squared. And to find the critical numbers of the cost function, we have to set up c prime of x equals 0. That is, first derivative equals 0. So I'm going to put a 0 here, and this equals 14 times of 1 is 14 minus 3150 over x squared. We now solve this equation for x. So I'm going to add this expression, that is 3150 over x squared to both sides. So therefore this becomes equals 14. Now you can solve for x. So first I multiply by x squared and then divide by 14 and solve for x. So x squared equals 3150 over 14. And this equals, we plug this into the calculator, we get 225. So therefore we see that x equals, we have to take the square root on both sides. We will get x equal to plus or minus 15, but here we use only the positive 15 because the side length x cannot be negative. So this is the critical number of the function. Now we will prepare a sign chart to determine whether the volume is minimum at this critical number. So we are preparing sign chart for the first derivative, and we have x equal to 15 over here. Now let's copy the, I'm sorry, this is a cost function. So we will find the derivative of the cost function, that is c prime of x. Now let me copy the derivative function, which is 14 minus 3150 over x squared. So c prime of x, this equals 14 minus 3150 over x squared. Now we can pick some random values before x equal to 15 and after x equal to 15. So I'm going to pick x equal to 1 to determine the sign of this interval, that is from negative infinity to positive 15, and the other interval is 15 greater than 15, that is 15 to infinity. So we can pick x equal to 1 in this interval and substitute in this cost function. So therefore this becomes c prime of 1 equals 14 minus 3150 over 1 square. And this is going to be negative because 14 is less when compared to 3150. And when we do the subtraction, we are going to get a negative number. So basically, we need to understand only the sign, whether it is greater than 0 or less than 0. So here it is negative. So we put negative over here, and now we pick another random value after in this interval, that is from 15 to infinity. So I can pick x equal to 16 and put in the c prime of x. So therefore it becomes c prime of 16. This equals 14 minus 3150 over 16 square. And when we plug this into the calculator, we get a negative number. So this is, I'm sorry, we get a positive number. So basically the sign of the first derivative of the cost function is positive here. So we can put positive over here. It is positive. Now since it is a negative in this interval, we can draw it like this. That is, the function is increasing and it reaches, I'm sorry, we have to do it otherwise. So since it is negative, it has to slope down like this, and it reaches the lowest point and then it increases. So clearly at x equal to 15, the cost function is minimum. So we see that at x equals 15, cost is minimum. Therefore, we can now determine the minimum cost by plugging x equal to 15 into the cost function. So let me copy the cost function c of x, and this equals 14x plus 3150 over x. This is 14x plus 3150 over x. Now we have to plug in x equal to 15 into this cost function to determine the minimum cost. So therefore this becomes c of 15. This equals 14 times of 15 plus 3150 over 15. So this equals 14 times of 15 equals 2000, sorry, it is 210 plus 3150 over 15, we get 210. So 210 plus 210 is 420. And so this is in, we have to put this in dollars because it represents the cost quantity. So we have determined the minimum cost, which is found to be $420.